In the heart of what is now the Gobi Desert, the Öösh Formation once sprawled across a lush, semi-arid floodplain during the early Cretaceous, around 130 million years ago. This ancient landscape was shaped by braided rivers and ephemeral lakes, nourishing a patchwork of conifer forests, ferns and horsetails beneath a warm, seasonal climate. The skies above this Mesozoic wilderness were traced by the shadows of pterosaurs, while turtles and crocodilian ancestors lurked in the meandering waterways. Palynological studies suggest the vegetation was dominated by gymnosperms, painting the landscape in shades of green unfamiliar to the barren sands of today. Periodic droughts punctuated the wet seasons, preserving layers of silts and sands that now cradle this lost world in stone. Among the most iconic inhabitants of this ecosystem was Psittacosaurus, a small, beaked dinosaur that thrived in the undergrowth. Remarkably, two distinct species of this genus have been discovered here, hinting at a surprising diversity within a single locality. These early ceratopsians were bipedal herbivores, their parrot-like beaks perfectly adapted for cropping tough, fibrous plants. Fossilized skin impressions reveal that Psittacosaurus bore a mosaic of scales and even possessed bristle-like structures on its tail, possibly for display or defense. These two species may not have been strictly contemporaneous, but could instead represent different stages in the evolutionary history of the genus within this region. Prodeinodon is a wastebasket taxon and a dubious genus of theropod dinosaur. Two species have been formally identified, with a third informal species, all three known only from tooth fragments, showing no diagnostic features, making them difficult to classify, though they may belong to a carnosaur. At least some of the referred species may represent basal carcharodontosaurid theropods similar to Acrocanthosaurus. Shanag was a small, feathered predator, measuring about 1.5 meters in length and weighing around 5 kilograms. Its fossilized jawbones reveal unique dental traits and skeletal features that link it to both dromaeosaurids and early birds. Though incapable of flight, Shanag likely used its feathered limbs for balance and agility, much like modern raptors gripping their prey. This agile hunter offers a glimpse into the complex evolutionary mosaic of theropods, blending traits of predators and protobirds. Gobiconodon was a predatory mammal, notable for its unusual pattern of tooth replacement. Unlike modern mammals, it repeatedly replaced its complex malariform teeth, a rare condition known as polyphyodonty. This trait, observed in multiple species, may have been linked to its relatively large body size and active lifestyle. Gobiconodon's dental evolution offers rare insight into the diverse and experimental nature of early mammalian biology. During the dawn of the early Cretaceous, the vast landscapes of the Xinminbao Group stretched from northern China into the fringes of ancient Mongolia, capturing a world in slow but steady transformation. This region, once marked by lush floodplains, had shifted toward more open woodlands and sprawling river systems under a drier, more seasonal climate. Conifer forests still clung to life along waterways, mingling with ferns and pockets of hardy cycads that spoke of resilience in the face of change. Wide floodplains gave way to lakes and ephemeral streams, shaping habitats where herds of dinosaurs left their passing traces in the mud. The Xinminbao landscapes reflect a world gradually opening up, its ecosystems more fragmented, its fauna more specialized. In these ancient soils, we glimpse the subtle pulse of deep time, as life answered the call of a changing earth. Psittacosaurus mazungtianensis is a species known from the Xinminbao Group, where it roamed the semi-arid floodplains. Slightly more gracile than some of its relatives, this species is distinguished by subtle differences in its skull and jaw, hinting at dietary specializations within its habitat. Like other Psittacosaurus, it was a bipedal herbivore, using its sharp, parrot-like beak to shear through tough vegetation. Its discovery in northern China adds to the picture of this genus as highly adaptable, thriving across varied environments and climates. Psittacosaurus mazungtianensis stands as a testament to the evolutionary success and resilience of these small ceratopsians during a time of ecological transition. The two known species of Microceratus of this ecosystem were small, lightly built ceratopsians, measuring 60 centimeters in length. They possessed slender limbs and a delicate frill, lacking the large horns of their later relatives, which made them agile runners through the undergrowth. Their sharp beaks and simple cheek teeth were well suited for cropping ferns, cycads, and other low-growing plants. With their light frames and keen senses, they likely relied on speed and vigilance to avoid the predators of their time. Archaeoceartops, like all ceratopsians, was an herbivore. During the Cretaceous, flowering plants were geographically limited on the landscape, and so it is likely that this dinosaur fed on the predominant plants of the era, ferns, cycads and conifers. It would have used its sharp beak to bite off the leaves or needles and chop them up to be swallowed. It appears to have been bipedal and quite small, reaching 90 centimeters in length and 10 kilograms in body mass. It had a comparatively large head but no horns, possessing only a small bony frill projecting from the back of its head. Auroraceratops was a small, bipedal neoceratopsian with a broad, flat skull and distinctive paired roughened areas likely covered in keratin. Unlike its close relatives, it had a short, wide snout and unique fang-like teeth at the front of its jaws. Fossil evidence from bone beds suggests it sometimes died in burrows, preserved in curled positions by rapid burial. This species adds to the diversity of early ceratopsians, showing anatomical traits not seen in more primitive forms like Archaeoceartops. Siluosaurus is a small and enigmatic ornithopod known only from two tiny fossil teeth discovered in the Xinminbao Group. These teeth, among the smallest attributed to any ornithopod, hint at a delicate, likely herbivorous animal adapted to nibbling soft vegetation. Though initially thought to be a hypsilopodontid, recent studies place it more cautiously within Sauropoda. With so little material available, Siluosaurus remains a shadowy figure in the early Cretaceous ecosystem. Gongpoquansaurus is a hadrosauroid, though originally thought to be a species of Probactrosaurus. It was since found to be a genus in its own right due to its closer relationship to other hadrosauroids than Probactrosaurus. It is known from portions of the body skeleton and some teeth and skull fragments coming from a juvenile individual. It came from the area and time that many hadrosauroids are known from, such as its close relative Equijurbus. Equijurbus is a relatively large euornithopod. Gregory Paul in 2010 estimated the length at 7 meters, the weight at 2.5 tons. A palpebral bone seems to be absent, meaning the eyes were not overshadowed by an upper rim as with most related species. It was described as a basal hadrosauroid dinosaur, although it may turn out to be a non-hadrosauroid iguanodont. Gobititan can be distinguished from other titanosauriforms based on features of the caudal vertebrae. Compared with advanced titanosaurs, where the number of caudal vertebrae had been reduced to less than 35, Gobititan had a relatively high number of caudal vertebrae, which was interpreted as a basal trait. Gregory Paul estimated that Gobititan was 20 meters long and weighed 20 tons. Beishanlong is of a considerable size, approximating the largest known individuals of Gallimimus, which have been estimated to reach 8 meters according to the description. Beishanlong is one of the largest definitive ornithomimosaurs yet described, though histological analysis shows that the holotype individual was still growing at its death. A histological study of the bone structure of the fibula found 13 or 14 growth lines, indicating the individual was subadult, though growth had already slowed. Sinornithoides was a small, bird-like troodontid measuring about 1.1 meters long and weighing roughly 2.5 kilograms. Its elongated skull featured unique traits, such as a rare small opening in the maxilla and closely spaced, recurved teeth without serrations on the front edges. Known for its advanced senses and high behavioral complexity, this dinosaur had large sickle claws and slender, lightly built limbs suited for agility. The discovery of a well-preserved skeleton, including a furcula and gastralia, offers rare insight into the anatomy of early Maniraptorans and their evolutionary links to birds. Noripterus was a pterosaur, boasting a wingspan of up to 4 meters and a sturdy, reinforced skull. Its distinctive tooth arrangement combined a toothless beak with strong, widely spaced teeth ideal for cracking hard-shelled prey. Unlike most pterosaurs, it had unusually flexible toe joints, suggesting it stood and moved more on its toes than its whole foot. This digitigrade posture, rare among pterosaurs, likely made it more agile and efficient on land. With stout body proportions, it may have been a skilled runner, relying on swift terrestrial movement to evade danger rather than taking to the skies. Noripterus thus reveals a unique blend of aerial and ground-adapted traits among its kind. The Khuren Dukh Formation of Mongolia preserves a snapshot of life during the early Cretaceous, in a world shaped by shifting rivers and ancient lakes. This landscape was a patchwork of floodplains and wetlands, where conifers, ferns, and horsetails thrived under a warm, seasonal climate marked by alternating wet and dry periods. Fossil evidence paints a picture of a rich ecosystem, home to small theropods, early ceratopsians, and mammals scurrying beneath the dense undergrowth. The sediments tell of periodic floods that preserved bones in fine silts, locking moments of life in time beneath layers of earth. Vegetation was likely dominated by gymnosperms and hardy understory plants, resilient to the region's climatic fluctuations. Khuren Dukh stands today as a window into a vanished world, where ancient life flourished in the shelter of forests and floodwaters. Qilian was a small, semi-aquatic, known for its elongated neck and tall, paddle-like tail used for swimming. Fossils from the Khuren Dukh Formation suggest it inhabited ancient lake environments alongside other choristideres. Although 2 species have been named, the validity of the Russian species remains uncertain due to limited material. Recent discoveries confirm Khuren Dukh as a basal member of the long-necked Hyphalosaurids, shedding light on the diversity of these unusual reptiles. Although technically a freshwater reptile, Quria is a member of an interesting yet often overlooked group known as choristideres. Despite its rather gharial-like appearance, this 1.5-meter-long animal wasn't related to any of the crocodilians. It was fully aquatic, spending its entire life in the water, and probably gave birth to live young. Choyrodon was a small iguanodontian ornithopod known from partial skeletons of subadult individuals. It combined primitive traits like an open antorbital fenestra with more derived features, such as a downturned jaw and enlarged nasal openings. Phylogenetic analyses suggest it was closely related to the North American Eolambia, rather than to its larger contemporary Alterinus. Despite their coexistence, differences in anatomy and bone histology confirm Qilian was not simply a juvenile form of Alterinus. Alterinus was a medium-sized iguanodontian herbivore, measuring between 6.5 and 8 meters in length. With an estimated weight of over a ton. It was primarily bipedal when moving but likely shifted to a quadrupedal stance while feeding, aided by strong, weight-bearing forelimbs with hoof-like fingers. Its wide muzzle and specialized beak suggest it was well adapted for grazing, paralleling the adaptations of modern grazing mammals. The distinctive arched nasal structure may have served for display, vocalization, or physiological functions, though its exact purpose remains uncertain. Iguanodon orientalis was named in 1952 based on fragmentary remains from the Khuren Dukh Formation, but its validity has long been questioned. The fossils are too incomplete and lack distinctive features to clearly differentiate them from other iguanodontians. Several studies, including those by Norman and Barrett, have suggested that it is a nomen dubium, meaning its classification is doubtful. Today, most paleontologists consider these remains to represent an indeterminate iguanodontian rather than a valid separate species. Harpymimus was a primitive ornithomimosaur, notable for retaining small teeth only in the lower jaw, unlike most of its toothless relatives. Its skull shows evidence of a beak and was likely used alongside the teeth for grasping rather than slicing food. Harpymimus shared some primitive features with Pelecanimimus but had fewer teeth, highlighting its transitional status within ornithomimosaurs. Estimated to weigh over 140 kilograms, it combined traits of later, more specialized ornithomimosaurs with features typical of earlier theropods. The Bayanshiree Formation, from the early late Cretaceous transition, reveals a world of lush floodplains and meandering rivers beneath warm, humid skies. This ancient ecosystem was a mosaic of woodlands and open areas, where ferns, cycads, conifers and early flowering plants thrived along the waterways. Seasonal rains likely transformed the lowlands into wetlands, supporting a rich diversity of herbivorous dinosaurs. Predators such as theropods stalked these fertile plains, leaving behind the fossil evidence of a dynamic food web. The climate was warm-temperate to subtropical, with high humidity fostering dense vegetation and abundant water sources. Fossilized plant material and sedimentology suggest periodic flooding shaped the landscape, depositing silts and sands that preserved the ancient life within. The Bayanshiree Formation offers a vivid glimpse into a vibrant, ever-changing ecosystem at a key moment in the evolution of Cretaceous Asia. Hybidus was a highly cosmopolitan genus of shark-like hybidont fish, known from a wide range of marine and freshwater deposits across the globe from the late Paleozoic to the end of the Cretaceous. Its success lay in its adaptability, with robust crushing teeth suited for a varied diet of hard-shelled prey like crustaceans and mollusks. The presence of Hybidus in the Bayanshiree Formation's river systems reflects its tolerance for brackish and freshwater environments, thriving in the dynamic floodplains alongside dinosaurs and other reptiles. Paralligator was a genus of Neosuchian crocodiliform that thrived in the freshwater ecosystems, with 2 recognized species discovered in the Bayanshiree Formation. These reptiles were medium-sized, with broad, flattened snouts and robust teeth adapted for crushing, suggesting a diet of hard-shelled prey like mollusks, crustaceans, and possibly turtles. Paralligator's anatomy reveals it was well suited to a semi-aquatic lifestyle, spending much of its time lurking in slow-moving rivers and lakes. Unlike modern crocodilians, it likely had a more varied ecological role, filling niches alongside fish and other aquatic predators. The coexistence of two species hints at subtle differences in habitat preference or feeding strategies to avoid direct competition. Talarurus was a medium-sized ankylosaurid, measuring around 6 meters in length and weighing up to 2 tons. Initially misunderstood in reconstructions, it possessed the typical ankylosaurid three-toed foot, a broad body, and a heavy tail club for defense. Recent studies of its skull reveal adaptations for low-frequency hearing and good gaze stabilization, suggesting sensory abilities specialized for ground-level foraging. Its broad, rectangular snout and robust build indicate a grazing lifestyle, feeding on low vegetation across flat landscapes. Sagantegia was a medium to large ankylosaur measuring 6 meters long and weighing between 1 to 4 tons. Its skull, about 40 centimeters in length, featured distinct amorphous and flattened cranial ornamentation, differing from the polygonal caputegulae seen in other Asian ankylosaurs. The long, flat snout with a pointed, U-shaped beak suggests specialized feeding adaptations. Compared to the broader, rectangular snout of the contemporary Talarurus, Sagantegia's shovel-shaped rostrum indicates it was likely a browser, feeding on higher vegetation, while Talarurus was adapted as a low-level grazer. The annoying thing about Amtocephale is that it is yet another pachycephalosaur genus that is known only from skull material, specifically the thick dome. The exciting thing about Amtocephale, however, is that at the time of its discovery it represents what might be the oldest known pachycephalosaur genus. Graciliceratops was a small ceratopsian dinosaur, estimated to be about 60 centimeters long as a juvenile, with adults likely reaching around 2 meters in length, comparable to Protoceratops. The specimen's delicate limb bones, including a gracile scapula and slender humerus, indicate a lightly built animal adapted to its environment. Graciliceratops was discovered in the Shirgin gas-hewn beds, which reveal a semi-arid climate with rivers and large lakes, alongside evidence of flowering plants from fossilized fruits, suggesting a diverse ecosystem. Gobihadros was a medium-sized hadrosauroid dinosaur, with individuals ranging from about 3 meters as juveniles to up to 7 meters in length when fully grown. It is distinguished by unique features such as a double-layered tomial edge of the premaxilla and the presence of up to 3 teeth per position in the lower jaw, traits that evolved in parallel to true hadrosaurids. Gobihadros also differed from related species by its undulating ilium profile and a distinctive spike-like claw on its first finger. Notably, a large, elderly specimen showed signs of calcium pyrophosphate deposition disease, indicating joint pain likely related to old age, as supported by bone growth patterns visible in CT scans. Kankolu, a medium-sized predator, offers crucial insights into early tyrannosaur evolution. Weighing around 750 kilograms, roughly the size of a horse, it was significantly smaller and more agile than its massive descendants like Tyrannosaurus rex. This dinosaur had small, rudimentary horns likely used for display or intimidation, and a long, shallow skull that lacked the bone-crushing power seen in later tyrannosaurs. Classified as a mesopredator, Kankolu relied on speed and agility to hunt prey, much like modern coyotes. Phylogenetic analyses position it as a close relative to Utarannosauria and a direct ancestor to both large, deep-snout Tyrannosaurini and smaller, shallow-snout Aleoramini. Its fossils, discovered in Mongolia's Bayanshiree Formation, support the idea that tyrannosaurs migrated between Asia and North America, with Kankolu or its kin crossing a land bridge to North America around 85 million years ago. This migration set the stage for the evolution of iconic apex predators like Tyrannosaurus rex, illuminating the complex biogeographic history of tyrannosaurs. Ovorkhangai, a small therizinosauride, measured around 3 meters long and weighed between 150 and 250 kilograms based on femoral estimates despite limited fossil material. Its skull, about 25 centimeters in length, reveals a lightly built animal with a long, shallow snout and a relatively weak bite force, adapted for browsing soft vegetation rather than chewing tough plant material. CT scans of the holotype's brain case indicate well-developed senses of smell, hearing, and balance, traits inherited from its carnivorous ancestors but repurposed for its herbivorous lifestyle. Enigmasaurus, a large therizinosaur measuring about 5 meters long and weighing up to 900 kilograms. It was likely a slow-moving herbivore or omnivore, sharing its habitat with relatives like Ovorkhangai and Segnosaurus. Its well-preserved pelvis shows unique features such as fused pubic feet forming a V-shaped structure and a flattened pubic boot with prominent processes, although some traits may reflect the advanced age of the individual rather than species-specific characteristics. Further study is needed to determine which pelvic traits truly define Enigmasaurus and clarify its place within therizinosaur evolution. Early researchers like Bars, Bold and Pearl suggested that Segnosaurus and related therizinosaurs had short, broad feet and large, splayed toes, indicating they were slow movers, possibly even amphibious. Subsequent studies supported their slow, bulky nature, with evidence pointing toward a primarily herbivorous or omnivorous diet, as indicated by their small skulls, beaks, weak teeth and large guts. Detailed analyses of therizinosaur brain cases reveal well-developed senses likely inherited from carnivorous ancestors but adapted for foraging and social behavior, while their massive claws were unlikely used for digging but possibly for defense or feeding. Dukh, a medium-sized therizinosaur, is unique among its relatives for possessing a didactyl hand, unlike the typical tridactyl condition of other therizinosaurs. This well-preserved specimen reveals that its strongly curved keratinous claws were adapted for grasping branches and vegetation, suggesting a selective feeding behavior consistent with an herbivorous or omnivorous diet. The morphology hand supports the hypothesis that derived therizinosaurs use their claws primarily for hook and pull foraging, though other functions such as defense or display cannot be ruled out. Garadomimus, unlike the more cursorial ornithomimids with powerful thighs and straight claws, had limb proportions and foot morphology suggesting it was not built for speed. Studies of its eye anatomy indicate it was likely cathemeral, consistent with its herbivorous lifestyle, contrasting with mostly nocturnal predatory theropods. Its jaw structure, featuring a beak and low bite force, along with specialized jaw musculature, supports an herbivorous or omnivorous diet relying on plucking and processing vegetation primarily through gut fermentation rather than oral processing. Aquilobator is one of the largest known dromaeosaurids, measuring up to 5 meters in length and weighing around 300 kilograms. Despite the absence of direct feather evidence on its holotype, close relatives strongly suggest it bore plumage. Its anatomy, including massive thighs, a propubic pelvis, and robust legs, indicates it was adapted for moderate-speed running and powerful leaping. However, limb proportion studies reveal it was not built for sustained high speeds, contrasting with more cursorial theropods. Functionally, its large sickle claw was likely adapted for aggressive predation rather than climbing, which aligns with its large size. Research comparing dromaeosaurid feet to modern birds of prey suggests Aquilobator used a raptor-like hunting strategy, leaping onto prey and restraining it with its claws while balancing with feathered limbs and tail. Its robust maxilla indicates a generalist diet, differing from the more specialized snout shapes seen in other Asian eudromaeosaurs. Overall, Aquilobator exemplifies a large, powerful predator that occupied a unique ecological niche among dromaeosaurids. Several mammal fossils have been discovered in the same geological formation, indicating a diverse and thriving small vertebrate community during that period. This suggests a complex ecosystem where mammals coexisted alongside large dinosaurs, contributing to a rich and balanced food web.